name is Scott Nowicki. I am a remote sensing scientist. I've done lots of academic work in the Mars and Earth remote sensing field. What we're doing today is a recreation in so many ways. 100 years ago, during the Roy Chapman Andrews expeditions that surveyed these areas and really determined where the fossils were getting exposed. For paleontology, for a long time it's been people roaming the desert looking for sites and then creating these geologic maps that they draw by hand. So we use the same stuff that we've used in space on satellites in order to kind of bring it down to this finer scale and map out locations, both on the rock layers themselves and the rocks, where fossils could be found. The sandstones, the mudstones, they're all indicative of a specific environment that occurred. We now know that if you go and look for these same types of layers, that they are likely to have fossils in them. This is the satellite imagery from ASTER, the Advanced Spaceborne Thermal Emission and Reflectance Radiometer. It's been flying for 17 years. So this is solid, reliable data at relatively low resolution, like 15 meters per pixel. So we can zoom in and you can see a lot of detail, but it's not, nowhere near the resolution that we get with drones. The technology that we're bringing of flying drones isn't really new. The new thing is putting the specific types of cameras we have on them and then folding this data together. So what this represents is a bunch of pictures, and so we can actually take imagery, drape it on the model, which we call orthographic representation of that surface. It's as though you're looking straight down at every single point. But this is like perfect collaboration of technology and background to potentially really figure out how it works. Find the fossils, find the layers, interpret the paleogeography of what was happening here, bring it all together into a model that we understand.